Hello everyone, welcome back to my channel. Today I'm here with the class 9th physics ICSE board chapter 2 motion in one dimension with its first exercise numerical portion. Firstly we are going to solve the unsolved numericals, then we will once discuss the solved numericals also. So let's start without wasting time. These are some of the important formulas or concepts which you must have to remind before solving the numericals. The first is 1 kilometer per hour is equals to 5 by 18 meter per second. Now this is very important that we can use in various numericals to convert the units from the kilometer per hour to the meter per second. How is this equal to 5 by 18 meter per second? Let's discuss once. As we know that 1 kilometer is equals to 1000 meters and 1 hour is equals to 60 minutes and 1 minute equals to 60 seconds. So if we want to convert 1 kilometer per hour into meter per second, we need to multiply the kilometer with the 1000 and this with the 3600 for the second. Now 2 zeros will cut with this. 5 2 5s are 10 and 2 18 the 36. So what we got, that is 5 by 18 in meter per second. That's why the 1 kilometer per hour is equals to 5 by 18 meter per second. Let's come to the second one, that is speed, which is explained with the notation v here in the chapter. It is equals to distance divided by time. The distance we will talk in this chapter in the form of s. T is for time. Next is the average speed. This is also most useful. The average speed is equals to the total distance traveled or covered divided by total time taken by the body, by the object. Next is the average velocity now. It is the displacement divided by the total time taken. Acceleration is, what is the define of the acceleration? That is the rate of change of velocity, means change in velocity with the time, which is also written as, acceleration is written in the form of a. Change in velocity means v minus u. What is v and u here? V is the final velocity and u is the initial velocity of the body. For example, if there is a car moving from this position A and reaching to the position B, the velocity at the point A is known as the initial velocity, its starting velocity at the starting point, and the B, that is the final velocity at the point B. If the car is at rest at the position A, it means the initial velocity is 0 meter per second. The next is, we can write it as A is equals to change in velocity means always final minus initial divided by the time interval, that is represented in t. Now if we will cross multiply these, that is a into t, we got is equals to v minus u. If I shift this u to the other side, I will get v is equals to u plus at, which is the equation of motion in the one dimension. This we can use in the next exercise also, in the 2C exercise. But in this exercise, this is mostly used, this one formula. So let's start with the first numerical now of exercise 2A, that is the unsolved numerical. So this is the first question, that is the speed of a car is given in kilometer per hour. We need to express it into the meter per second. So this one relation we will use here. 1 kilometer per hour is equals to 5 by 18 meter per second. So how to solve it? 72 multiplied by 5 by 18, then after doing multiplication it will change into the meter per second. Now here we can do the cutting on the table of 2. 2 9s are 18, 2 3s are and 2 6s are, 9 4s are 36. So we are left with 4 into 5 meter per second, which is equals to 5 4s are 20 meter per second is your answer. The next numerical is express 15 meter per second into the kilometer per hour now. As we know that 1 kilometer per hour is equals to 5 by 18 meter per second. So if I want to convert from meter per second to kilometer per hour, I need to multiply the 15 with the reciprocal of this, with the opposite of this. That is 18 by 5 for the kilometer per hour. 5 3s are 15. We are left with 3 into 18, which is equals to 54 kilometer per hour. The next question is, the question is express each of the following in meter per second. The first is given in the kilometer per hour and the second is given in the kilometer per minute. So here we can use easily this formula, but for this we need to do the different conversion. So for the first part, that is 10 kilometer per hour, we can write it as 10 into 5 by 18 meter per second. That is 25 by 9 meter per second. I did the cutting of this on the table of 2. 2 5s are 10 and 2 9s are 18. 25 by 9, which I can write as 2.78 meter per second. The second part is, this is your answer. Second part is 18 kilometer per minute. For kilometer, 18 into 1000 we will do. It will change into meter. Divided by minute, it is 1 minute is equals to 60 seconds. So now it changed into second. 1 0 is cancelled out with 1. 6 3s are 18. It is 300 meter per second is your answer. Now question number 4. These three we are having with, the question is arrange the following speeds in the increasing order. 3 speeds are given to us. Firstly, for comparing these, for arranging into the increasing order, we need to make the units of these 3 same. Then only we will compare the numerical values with each other. So for this, we are keeping the meter per second as it is. I am writing it as it is. This is my first value, second value and the third value. I am writing the first one as it is and the second I am converting into the meter per second. So I am multiplying the kilometer with the 1000 for converting into meter, and 1 minute with the 60 second to convert into the second, and 18 I need to convert into the meter per second. So 1 kilometer per hour is equals to, I know, 5 by 18 meter per second. I will get this. Meter per second after cutting these two, that is 13.9 meter per second and 5 meter per second. So this is the at the first number now. Okay, this is actually the third one. Then second this will come, third this will come, because we need to arrange these into the increasing order. So firstly I'm going to write 5 meter per second, then 10 meter per second, then 13.9 meter per second. If I will arrange these into the original question form, I will get, this is at the first number, that is the number 3, 18 kilometer per hour is lesser. Then at the second, this 10 meter per second. Then at the third, it is 1 kilometer per minute. It means this is the most greatest one. Clear? Then the question number 5 is, the next question is, a train takes 3 hours to travel from Agra to Delhi with the uniform speed of this, and find the distance between the two cities. Firstly, we are going to write what the things are given to us. The time is given, that is 3 hours. Speed of the train is given, which is 65 kilometer per hour, and we wanted to find the distance. What is the formula for speed? The speed is equals to distance over time. But here we need to find the time. So we are rearranging the formula. That is, the distance is equals to speed multiplied by time. So S is equals to, the value of speed is 65 kilometer per hour into 3 hour. That is 195 kilometer per hour will cancel down with this hour unit. So the distance is in the kilometer, that is 195 kilometer. This is your answer. Question number 6 now. The next question is, a car travels first 30 kilometer with the uniform speed of 60 kilometer per hour. What is given? A car is traveling with the distance is given 30 kilometer. The speed is given 60 kilometer per hour, and then next 30 kilometer with the uniform speed of 40 kilometer per hour. Means this is the case 1. Now for the case 2, car traveled the distance again same 30 kilometer, but the speed now is 40 kilometer per hour. We need to find the total time and average speed. So what to do firstly? Firstly, we need to find the time taken by the each case. Then we will add on that time. We will get the total time taken by the car. So for the first one, that we know the speed is equals to what? The speed is equals to distance divided by time. Speed is equals to distance over time. Time we need to find out. For finding time, the relation will become like distance divided by speed. So for the first case, T1 is equals to distance 1 is 30 and the speed is at that time is 60. So it is 1 by 2 in hour it is. And T2 is distance is 30 again. And the speed is 40 kilometer per hour. That is 3 by 4 hour. So for finding the total time of the journey, total time taken, we will add these two. 1 by 2 plus 3 by 4 in hour, the answer will come. That is 2 plus 3, which is equals to 5 by 4 hour. That is the total time of the journey. Now this answer, if you want to convert into the minute also, you can convert into minute as well. That is 5 by 4 hour is equals to 5 by 4 into 60, because 1 hour is equals to 60 minute. So after doing cutting and all, we will get the answer for this in the minute as well. The next second part is the average speed. For the average speed now, we know the formula for average speed is equals to total distance covered or traveled divided by the total time of journey. So what is the total distance? It is 30 and 30, that is a 60 total. So 60 kilometer is the total distance, and total time we just find out, that is 5 by 4 hour. Which is equals to 60 into 5 by 4 is 4 by 5 in the kilometer per hour. Answer will come. So after doing the cutting, we are getting 12 into 4, which is 48 kilometer per hour is your answer for the average speed of this question. Now let's move to the question number 7. It's the 7th numerical. Question number 7 is the train takes 2 hours to reach station B from station A. Means this is the station A, station B. From station A to station B, the train is taking 2 hours. And then 3 hours to return, and then 3 hours to return from station B to A. The distance between the two stations is 200 kilometer. This distance is the 200 kilometer. Find the average speed. Average speed we have to find out, and the average velocity of the train. So let's start with the question. Average speed is equals to, what is the formula for the average speed? It is equals to total distance covered divided by total time taken. So average speed is equals to total distance traveled. How much? That is a 200 to this side and 200 back also. It is the 400 in total. 400 kilometer divided by total time of the journey. 200 to this side and 2 hour to this side and 3 hour to this side. 2 plus 3 is 5 hour. And the distance is 400. How that is clear? 200, that is the gap difference between the two different stations. So 200 plus 200, because the train is going and coming back, it is the 400 in total divided by 5. It is equals to 80 kilometer per hour. Then the next is, we have to find the average velocity as well. What is the formula for the average velocity? For the average velocity, it is equals to displacement divided by time. Average velocity is equals to displacement divided by time. Now what is the displacement here? The displacement is 0. How 0? Because the train is moving from the first station to the station B and coming back to the same position again. It means there is the no difference, no distance traveled by it. It is showing that, because what is the displacement? It is the difference between the initial and the final position. So there is no any difference. It means the average velocity is 0 here. 0 meter per second. The next is the question number 8 now. Question number 8 is, a car moving on a straight path covers a distance of 1 kilometer due east in 100 seconds. What is the speed and what is the velocity of the car? Firstly, we are going to write what are the things given. The distance covered by car is 1 kilometer. And in how much time? It is in the 100 seconds. We need to find the speed firstly. The formula of speed is equals to distance divided by time. Distance is 1 kilometer. Time is 100 seconds. You can convert it into the meter also. The answer is 10 meter per second. This is for the speed. Second is for the velocity. What is the velocity? Velocity is also equals to speed. Both are having same thing, but due east it was moving. So the velocity is also 10 meter per second and it is due east. This is your answer. The next is numerical number 9. Question number 9 is, a body starts from rest. Starts from rest means initial velocity is 0 meter per second and requires the velocity of this, means final velocity is 10 meter per second in 2 seconds. Time is also given. We have to find the acceleration. What is the formula for acceleration? It is equals to A is equals to V minus U by T. So A is equals to V minus U divided by T. It is 10 by 2 is equals to 5 meter per second square. So A is equals to 5 meter per second square. Question number 10. Question number 10 is a car starting from rest. Car starting from rest means initial velocity is 0 and acquires a velocity of 180 meter per second. In time is given 0.05 hour. We have to find the acceleration again. Firstly, I am converting the time into the second. So 0.05, this I can write as by dividing with 100. R I want to change into the second, so I need to multiply it with 3600 for the second. Then 5 into 36 is left with me. This seconds. Okay, so we are going to apply the formula. Now you can solve this also, otherwise I'm doing the next part, that is A is equals to V minus U by T is the formula which we are going to apply here, because A we need to find and the value of V is 180, U is 0, time is 5 into 36, it is equals to 180 by 5 into 36, 5 3s are 15, 5 6 are 30. So 36 by 36 is equals to 1 meter per second square. This is the value of the acceleration. Meter per second square are the SI units for the acceleration. This is your answer. Question number 11 now. What is the 11th question now? A body is moving vertically upwards. It means the acceleration will come in the negative form here. Its velocity changes at a constant rate from this to this. From this means it is the initial velocity and the final velocity is 20 meter per second and the time 3 seconds. The acceleration we need to find out. Acceleration is equals to V minus U by T, we know. So V minus U divided by T is equals to minus 30 by 3. So A is equals to minus 10 meter per second square. See, the units are same. Yes. So A is equals to this value. Now we can also write that A is equals to, or the retardation is equals to, retardation is 10 meter per second square in this case. Otherwise you can give the sign of negative in the front of the value of A, because the body is moving up vertically upward, that is opposite to the gravitational force. Question number 12 now. The question is a toy car initially moving with the uniform velocity of this. Uniform velocity, initial velocity is given in the kilometer per hour and comes to stop means the final velocity is 0. In the time 2 seconds, we have to find the acceleration. It is actually the retardation. So the value will come in the negative sign. The next thing is, this is given in the kilometer per hour. We need to convert it into the meter per second by multiplying with 5 by 18 and we will get 5 meter per second. So now the formula of A is equals to V minus U by T, that is equals to 0 meter per second minus 5 meter per second inverse divided by 2. It is equals to minus 5 by 2, which is minus 2.5 meter per second square. So the value of acceleration is A is this. Question number 13 now, 13th numerical. What is the question? A car accelerates at the rate of 5 meter per second square. Acceleration in this case is given to us. Find the increase in its velocity in 2 seconds. The final velocity we need to find, initial velocity means is 0 and T is the 2 seconds. So A is equals to V minus U by T, that is equals to 5 meter per second square is equals to V minus 0 by 2, or 10 meter per second square is equals to V. So this is the, it's per second now here, because this is also in the second. So the V is equals to 10 meter per second is your answer. Now question number 14. Question 14 is, a car is moving with the velocity of 20 meter per second. The brakes are applied to retard it at the rate of this. Okay, the initial velocity is given to us. U is the initial velocity that the car is moving with this speed, and we wanted to stop the car. The brakes are applied to retard at the rate of 2 meter per second. Okay, second initial velocity is given, final velocity is not given. The acceleration is retarding actually, so the negative sign will come, that is minus 2 meter per second square. What will be the velocity after 5 seconds? Actually, the car is stopping after applying brakes, but at t is equals to 5 seconds, we want to find the final velocity of it. So firstly check, are all the units in the same? Yes. So a is equals to v minus u by t, same relation of the acceleration. A is equals to minus of 2 meter per second square, which is equals to v I need to find out. Put the other things, that is minus, if I will multiply this, we'll get minus of 10 meter per second is equals to v minus 20 meter per second, and minus of 10 meter per second plus 20 meter per second is equals to v. Thus v is equals to 10 meter per second square inverse. Question number 15 now. The 15th numerical is, a bicycle initially moving with the velocity of this. The initial velocity of a bicycle is given 5.0 meter per second with the acceleration of 2 meter per second square in time 5 seconds. What will be the final velocity? Final velocity is question mark. Again the same relation we will use, 2 meter per second square is equals to v minus u divided by 5 seconds, that is 5 to the 10 meter per second is equals to v minus 5 meter per second, which is further equals to, this will go in the plus form there, it will give us answer 15 meter per second, because this 5 when we'll move to other side it will become plus of 5, 10 plus 5 is 15 meter per second is the answer for the velocity, final velocity it is. Now question number 16 and the last numerical of this exercise. Question number 16 is, a car is moving in a straight line with the speed is given. Speed is given 18 kilometer per hour and it is stopped in the 5 seconds. So time is 5 seconds after applying the brakes. Find the speed of the car in meter per second. First is, speed is already given, we need to find it into the meter per second, so multiply with 5 by 18, it will convert into meter per second. The answer is 5 meter per second you will get. The next thing is, as we are applying the brakes to it, so it means the final velocity is 0 meter per second. The second thing is, we need to find the retardation for it. Retardation means the value of a will come in the negative form, so we are using the same formula here also. What is the value of v? It is 0 minus initial velocity is, initial velocity means the speed with which it is moving, that is its initial velocity, and that we just converted into the meter per second, so I am using this value here because this is the 18 kilometer per hour, hai, but I am using the meter per second value because I have done the conversion, so I am using the converted value, and the time is 5 seconds. It means a is equals to minus 5 by 5, the a is equals to minus 1 meter per second square is the answer for the acceleration. The next part is first also done, speed conversion into the meter per second, retardation also done. The third part is we need to find the speed of car after 2 seconds of applying the brakes. So what is we need to find? We need to find the speed of it. We need to find the S actually. What is the formula for it? Means we need to find the final velocity for it. Speed means the final velocity when the brakes are applied for the 2 seconds after that. So it is A is equals to V minus U by T. Speed of car after 2 seconds of applying brakes. Means we are applying the brakes only for the 2 seconds. After that, what is the speed that we need to find out. The retardation we just found, that is minus of 1 meter per second square is equals to we need to find. And the U is the initial velocity, which is the 5 meter per second. Time is also 5. So minus 5 meter per second, that will come to plus here this way. Here because we needed to find the speed when the after the 2 seconds of the applying the brake. So it means the time we are taking the 2 seconds here. That's why it is here this. A, it is minus of 1 meter per second square that we found just. V as it is, because we need to find the average. We need to find the speed after the brakes are applied after the 2 seconds of it. Means we need to find the final velocity actually. And the initial velocity is 5 meter per second divided by the 2 second. It is equals to, after doing the cross multiplication, that is minus of 2 meter per second. It is equals to V minus 5 meter per second, which is V is equals to, this will go and come in the form of addition, that is 5 meter per second minus of 2 meter per second. The sign of 5 is positive here, you can see this as it is this side. I just shifted the minus 5 to this way, that is V is equals to 3 meter per second. This is your final answer. And the numericals of the exercise, which are the unsolved, are completed. Now let's take a look on the solved numericals also of this exercise. The first is select the scalars and the vectors from the following. What are the scalars? Those who are having only the magnitude. Vectors are having both the direction and magnitude as well. So velocity, acceleration, retardation, these are having the particular direction. That's why these are the vectors. Distance, work, mass, these are not having the direction. So these are the scalar quantities. Next question is, we need to express this into the meter per second. We just solved this also. 36, if I will multiply the 36 with the 5 by 18, then also I will get my answer. 18 to the 5 to the 10 meter per second. This is also the easiest way. Like this also you can do. The third numerical is, find the distance traveled by a body in 5 minutes if it travels with a uniform speed of 20 meter per second. Distance we need to find out. Time is given. The speed is given. What is the formula for it? Distance is equals to speed multiply time. Fill the values, you will get the answer. The fourth numerical is also very easy. So you need to see this by yourself. The question is, the train moving with the uniform speed covers distance in this time. We need to find the speed of the train and the time it will take to cover the distance of 240 meter. Means the double distance of this. 2 is numerical. This is also, just apply the formula of speed. Speed is equals to distance divided by time. You will get the first answer. Second answer, multiply this 2 with the 2 second more. 4 second is the answer for it. Now the next is question number 5. The fifth one is, a body rises vertically up to the height of minus 125 meter in 5 seconds. This is the distance covered in this time. Then come back to the point of the projection. Means the final position is the same. Displacement is 0. Find the distance traveled by it. Total distance traveled means it is going, body is going up and coming back down. S plus S is 2S we are taking. What is the value of distance given? That is 125. You will get the total distance. Now in this case, the average speed we need to find. Second is the displacement. Body is going up, coming back to the same position. Displacement is 0 in this case. 0 it is. Average speed is total distance divided by the total time. Total distance is 2S. Total time is 2 into T. The time is given 5 seconds. 2 times of that time. You will get your answer. The average velocity is displacement divided by time taken. Displacement is 0. So the average velocity is also 0. Next is question number 6. A train first travels for 30 minutes with the velocity of this, then 40 minutes with the velocity of this in the same direction. Two cases are there. First is this one, second case is this one. We need to find the total distance traveled. Total distance traveled, how we will find? Speed is given, time is given. Firstly, we will find the distance traveled from the first case. From the first case we found the distance traveled. From the second case we found the distance traveled. Then add that both distances. This is the first answer, total distance traveled. Then average velocity of the train, it is equals to total distance traveled divided by the total time of the journey. So total time of the journey is, we just converted these into the per second. That is in the minute already. But as the speed is given in the per hour, so we converted this minute also into hour. Because we need the same units, that's why. Then the time total is this and the total distance covered is this, we know. It means after dividing both these two things, we will get your answer. Question number 7 numerical is, a car travels a distance of this with the velocity of this. Speed is given, distance is given. Then again one another case is given. We need to calculate the total time of the journey. Firstly, we will calculate the time for the first case. For the second case, add that both, you will get the total time. Average velocity is displacement divided by time. Displacement is how much distance it is, the difference between the initial and the final position. So because two different distances they are covering here, so this is a displacement, total distance covered, or also we can say divided by the total time that we already just found. So divide these two, you will get your answer. The next one, 8th, is the velocity of an object increases at the constant rate. Velocity of the object increases at the constant rate from this to this, initial to final velocity in 10 seconds. Acceleration we want to find, apply the formula, simply you will get the answer. Check the units, all are in the same unit. Question number 9 is, a pebble thrown vertically upward with an initial velocity this comes to the stop in 5 seconds, means final velocity is 0. We need to find the retardation because it is moving vertically up. So answer of the A will come in negative form. You can write the value of A is equals to minus of 10 meter per second square, or retardation also you can write simply without giving any negative sign, because the meaning of retardation is it is opposite of the acceleration. So this is your answer. Next question number 10 is very easy. Solution is given. You can just simply check this question. If you find this video helpful, please subscribe to my channel, like the video, share with your friends, comment which topic or any other thing you want. I'll surely try to provide you. Thank you. Have a nice day.